Hello and welcome back to the GraphQL Radio podcast. My name is Max. I'm the CEO at Stellate, where we do GraphQL edge caching. And I'm here today with Sandro from Hashnode. Sandro, so nice to see you. Thank you for coming on.
Thank you so much, Max. Thank you so much for the introduction.
Yeah, I would love to start off with giving people a bit of context on Hashnode and on what you do at Hashnode. Sort of what is Hashnode? What are you using GraphQL for? What scale are you running at? And then also, who are you? And what do you do at Hashnode?
Yeah, definitely. So maybe I give you a quick introduction, then we dive deeper into the topic. So my name is Alessandro Volpicella. I'm 29 years old. I live in Munich, Germany, so right in the south of Germany. I think pretty close to where Max grew up in Austria. I'm a full stack engineer. So I work a lot with AWS, so a lot with serverless services, but also a lot with web development technologies like React. At the moment, I work at Hashnode. So I'm a platform engineering lead at Hashnode. So I take care of all of the cloud infrastructure over there. The integration of AWS is a huge part of my work. The integration with Stellate, Tinybird, Vercel, so all of these third-party providers that build up our platform. And what we do at Hashnode is a developer blogging platform. That means you as a developer can come to Hashnode, create your blog within a minute and start blogging. And we provide you with all the tools you need for that. On the side, I love to tinker around with different projects and products. I love to build digital products. I've wrote a book about AWS fundamentals together with a friend. I have a few side projects going on. And yeah, I just love to build these products and talk about them and create content about that.
That's amazing. When you think about now working at Hashnode at this developer content platform, sort of running a lot of the AWS side of things, serverless architecture, making sure everything runs very efficiently, how did you end up getting there?
Yeah, that's an interesting question. So in general, how I got into tech is I've really early on during school, I started working with, just working with computers, not just gaming on computers, but really tinkering around with different things, build my own PC, build my first HTML websites and stuff like that. You do really early on. In Germany, you have these weird Teach with Eddie books, and there was like Teach with Eddie, build your first HTML site. And this is what I did really early on. But I was really bad at school and I hated school. So I stopped middle school after 16, I think, and did an apprenticeship. And the apprenticeship is a pretty unique thing in Germany, I believe. So you basically do full-time work and do school on the side. And I did this already in computer science. So went down the route of kind of a network engineer, system administrator. Maybe fast forwarding a bit is then I studied computer science at some point and did computer science for business and a master's in computer science, and worked in really every role in IT you can have, from quality management, was really hooked up in data science and then software engineering. And I was really lucky to do my bachelor thesis together with BMW, where I did something in data science, but the requirement there was really to come up with a with a whole product out of this project and not just do some small Jupyter notebook or some research thesis. And this is how I've learned to build a fully fleshed digital product with React, with AWS services, and with some data science backend, basically. So this is like the story how I got into tech in 2 minutes. And how I got into Hashnode, I think, was really interesting because after my studies, I just worked as an IT consultant, worked a lot in enterprise projects. But at some point, it was quite boring, to be honest. You know, these enterprise projects can be quite big and quite, not too interesting. So I started doing some side projects, did a mobile application where you can track your finances, your ETF stocks and stuff, and went into the whole Twitter bubble of software engineering, of indie hacking, and thought it was super interesting. And at the same point, I also thought, okay, I'm also doing interesting things. So I started creating content. And I think this was the major switch in my life, where I started creating blog posts on Hashnode and started creating tweets and had an audience and had like new friends online. And this is how Hashnode saw my one of my blog posts that blew up on Hacker News. And then Sandeep, the CTO, reached out to me and said, hey, we just raised Series A. Do you want to build Hashnode with us? And I said yes. And this is how I got started at Hashnode.
That's awesome. Building a developer blogging platform and then using it to hire for your own team with all the great people that you see. Writing posts is a very smart strategic move, it feels like.
Yeah, it is. That's true. Props to him, definitely.
Nice. I also love that your bachelor thesis was actually something useful. I think a lot of times people end up writing their bachelor or even master's thesis kind of because they have to, but don't do anything useful with it. They sort of just end up writing about some research that nobody really cares about and then move on to the next part of their studies. It's awesome that you got the chance to do something actually practically relevant.
Yeah, definitely.
When you think about Hashnode sort of today, what kind of scale does this system run at?
So Hashnode has over 600,000 registered users. So Hashnode in general has two sides you need to imagine. So we have one side is the writer. So when I started my blog, I go to Hashnode, register, so I'm a registered user. I connect my blog with a custom domain most of the times. So we have over 10,000 blogs with a custom domain. And then the other side are readers. And readers is everybody who finds a blog post which is hosted on Hashnode. And the reading side is growing organically due to SEO mainly. And we have over 3 million unique readers a month. That means everybody who looks for GraphQL edge caching and finds a Stellate blog post hosted on my blog, for example, is a unique reader. And there we have over 3 million readers. And I think the amazing thing from my perspective is that the whole project really was built with around 8 to 10 engineers. So that really shows how easy it is nowadays if you choose the right technology stack and have the right people to build something that serves millions of people.
I totally agree. I think that's one of the most powerful things about all these modern technologies. People complain sometimes about the cloud and how complex AWS is, but when you think about it, before AWS, you had to set up an actual rack of servers somewhere. And so you had to have literally full stack knowledge from like literally plugging a machine into a rack, plugging the power in, setting up the kernel and everything on there, making sure that you have a web server running, making sure it all stays up, right? You have to do the whole thing almost from scratch. I mean, you can always go a little further. You could argue that eventually you have to build your own processor, but you get to know a lot more things in order to build anything. And not only that, but then to scale, you needed to have a ton of knowledge on how to operationalize it. And now the cloud actually does a lot of that. Maybe let's start with sort of like, I would love a quick overview over the architecture that you have for Hashnode. How do you support that level of traffic and growth at that scale right now? What does that architecture look like? And maybe also what are some of the key pieces that have changed over time that worked particularly well, or that maybe you've switched out because they didn't work as you scaled?
Yeah, that's definitely a great question. So about AWS, I also think they are just democratizing how we can build things. So I have a huge blog post about the overall architecture of Hashnode. So people who are listening to this can who listen to this can maybe also check out this blog post because it's easier with a diagram. But what we use first of all is we are heavily invested in Vercel. So all our Next.js projects are deployed on Vercel, and we make use of Vercel especially for domains. We have a lot of custom domains. Like I said, you can just connect your custom domain to us, and this is all handled by Vercel simply via APIs. So if I think about a request, a user is coming to Hashnode, there are two places to go. One is hashnode.com. This is the community side of things. So we have a personalized feed. You see blog posts of other people, of other companies, or you go directly to a blog front end. You go to the AWS Fundamentals blog, for example, then you go directly to Vercel or to Cloudflare, depending on what you're doing. The next step is the page cache by Vercel. And I think this is a pretty interesting topic. What was also quite new for me is that on Vercel you can server-side render your pages, or Next.js you can server-side render your pages, and Vercel edge caches the whole HTML for you, not just the response of the API, but also the HTML, and puts this on their CDN on the edge. And the benefit there is, of course, the latency is much faster or much shorter because it's closer to the user. And also there's no rendering going on anymore. The whole HTML is instantly available for the user. So the page cache is a great concept for us, and we make use of that. But it also has a few gimmicks, so I can't go more into detail here with some of these issues, but we basically simply cache it for a short time duration, and that's it, what we do at Hashnode. The next part, if it's not available in the cache or if it needs to be revalidated, then we go to Next.js. Next.js is also deployed on Vercel. We have Next.js uses some get server-side props, Lambda functions in the end. They run over there. And then the request comes to an API cache. And this is, I think, where it gets really interesting. So all our APIs are cached, and we have one major GraphQL API, which is cached with Stellate. And we have a few other APIs, unfortunately, 2 other APIs mainly, which handle our business context as well, which is a monolithic REST API in an Express server and Next.js API functions. And these are also cached by Vercel. I say unfortunately because, of course, we are an early stage startup, so tech debt is always there. But having multiple APIs can definitely be an issue. And I think our GraphQL API now is the go forward. So this is really the way we want to go. But we also have the legacy API and some Next.js functions.
If I may double click on that for a second before you move on with the API overview, what was the decision like to sort of move to GraphQL, and why do you have a separate API there? And sort of where does that come from historically, and sort of what does the future of that look like?
Yeah, I think the history is most important. So first of all, we had a monolithic REST API in Express. When we moved to Vercel, because at that time we weren't on Vercel, when we moved to Vercel, developers started using the API functions. So everything you have in pages/API is an API function, and they made use of that extensively. And this is quite nice at the beginning, but this can get quite messy, because if you have multiple developers and worst case multiple repositories using these APIs, you have database accesses everywhere, and enforcing standards, reusing code, or caching are real issues there. For example, you can't invalidate the caches there, which basically you don't have a cache then. So this was really, really hard. And the last point, then we created a mobile application. The mobile application didn't have access at all to any of these Next.js functions. So we needed to create our own API. Why GraphQL and not REST? I think that's also really interesting, because if you think about blogging data, I think this is the hello world of each GraphQL API, because I have a blog. I want to get the first 10 posts of my blog. Then I need some additional data about the author of one blog post. And maybe I have a hover card where I show more posts of this author. So again, I need posts and this blogs. So the relations of our data are just so tightly connected that it just makes sense to have a graph of data there. So this is why we chose GraphQL in the first place.
I see. And so sort of all the legacy API that you use on hashnode.com and for the custom domain sort of sits within Vercel in these functions, but then anything that you need for the mobile apps and also anything sort of new gets built in the GraphQL layer that you now have.
Exactly. We've migrated quite a bit to the GraphQL API, because the GraphQL API is also available publicly. So this was also the second goal of this API, that everybody can use these APIs and doesn't need to use our front end, but can bring their own front end. So using Hashnode as a headless CMS. And we slowly try to get rid of the other APIs, but this is of course an ongoing process.
I can only imagine, yeah. All right, so just make sure I have it correctly. Sort of the actual front end is built with Next.js, hosted on Vercel. There's sort of an HTML page cache. You mentioned when it's not cached, it goes through to the APIs, fetches data from there, and then renders. You mentioned Cloudflare. What's Cloudflare used for? How does that piece fit in?
So if you go to hashnode.com, which is our community front end, Cloudflare is only there as our DNS system and our DDoS protection especially. So we don't use any Cloudflare workers, no database, nothing else, just DDoS protection.
Got it. And then what does the cloud side of things look like? So you have these APIs, where do they run? How do they run? What does all of that architecture looks like?
Yeah, so this is the part I love talking about, of course. So Hashnode runs on, we have many events, so we run on an event-driven architecture. Let's keep it like that. So each API we have, and mainly our GraphQL API, is emitting events. So once somebody, for example, once you publish a post, we emit an event to EventBridge, which runs on AWS, and we emit an event with post published and some data about this post. And from there on, everything runs asynchronously. So the whole part I'm talking about now runs all on AWS. And the event orchestrator is EventBridge. So EventBridge receives an event, and we have different consumers who subscribe to events. For example, for the post publish event, some Lambda functions subscribe to them and check, okay, has the user webhooks configured? If the user has webhook configured, then launch some step function, call these webhooks. Or has the user newsletter subscribers? If yes, send newsletter to these users. So the whole architecture is decoupled from each other, which was my major part of work in the last 1.5 years. And we can flexible just subscribe to events and unsubscribe from events without touching any APIs and any synchronous processes.
Let me actually ask one question about this, because I'm curious. When you think about modeling your API and particularly your client UI in this architecture, let's say I press the publish button. That sends a request to some API that says publish, right? Which publishes the event to EventBridge and says, hey, please publish this blog post. When does the loading state on the client actually resolve and redirect to the published blog post? Do you poll either on the client or in the API? What does that look like in practice?
So I think the loading state is really the best distinguisher between what is synchronous and what is asynchronous here. So once I hit publish, I hit the GraphQL API, have a mutation of publish post. Once I have created the post in the database, so only the most crucial flow for the user is done, we instantly return, and the synchronous part is done. And at the same time, we've emitted an event. So if the database transaction was successful, we emit an event to EventBridge, but this is done in a few milliseconds. Because we don't poll for everything, we don't wait for everything. Because the idea of the asynchronous processing is really, this is not needed for the user right now. It's okay if the emails are sent out 5 seconds later, or if the webhook is called a second later. There's no need to block the user from continuing to work with your product.
That's awesome. So in a way, you have most things offloaded to background processes that sort of run asynchronously through this event bridge. This is similar to what we did at Spectrum back in 2018. We had a much less advanced setup of this, but we were using Redis as a job queue, and we didn't enforce it, I think, as strictly as you're saying you're doing. It wasn't like a core part of the architecture, but we did have a queue that we pushed events to whenever things happen and whenever we needed to do background processing, particularly, right? Often for us, it was similar to you, like sending out newsletters or sending out notifications. I remember our notification system was a mess. So we just had background workers doing a lot of that, but we didn't do it quite as, I think what I'm hearing you say, as sort of extensively as you do, where really only the most minimal processes necessary run in the actual API, and everything else happens asynchronously and updates over time, which is beautiful.
That was also an evolving process. We started out with creating audio, because you can't wait for creating audio. It takes ages if you have huge blog posts. And then we saw the beauty of it and evolved the whole architecture.
Nice, that's awesome. All right, so your event-driven architecture on the back end, what does the rest of the architecture look like here? What database, what other parts of the system are there?
So I think the main data store, the main part that is missing is the persistence. So the data stores, we have MongoDB Atlas as a data store. So MongoDB, which is deployed on Atlas, not on AWS. This is the major part really. So in your NoSQL database, it is okay to work with it. It can be quite hard to, if you have serverless consumers, can be quite interesting because the two models of connections and serverless consumers don't fit 100%. And other than that, we have Firestore, where we host all of our drafts. So if you create a blog post, we synchronize them all the time with Firestore. Was made mostly legacy decisions why we don't have them on MongoDB. And the third part we have is Redis on Upstash. And this was just a recent project, which was also pretty interesting because we have this personalized feed I mentioned earlier. So for each user, we pre-calculate a personalized feed. So kind of a social media, Twitter, Facebook feed. And to scale this whole feed, it can be quite a challenge because we have so many database access and so many different factors that come into this feed that we now fan it out and pre-calculate it for active users.
And that is all stored sort of in Redis. And in Redis then, just out of personal curiosity, what does the data structure look like in Redis? Do you store like post IDs for each user? Do you store the whole post information? How far do you go there?
We have some metadata in Redis. So for example, we get a pool of 1,500 latest posts and we don't want to get them from the database. So sort of these user metadata, likes, reading history and stuff like that is stored. And the feed is one set, is a sorted set for each active user. And then we have a ranking score and the post ID to this ranking store, and this is then the sorted set what we store.
That's awesome. All right, so and then one more question. As far as I remember, does MongoDB Atlas do like region replication? Is that why you use Atlas, or what brought you to Atlas versus hosting and staying within AWS?
To be honest, I think it was before my time. I think it was mainly because it was the ease of deployment. We don't use any global tables or region replication. Not yet. This is mainly why we use an edge cache.
Got it. Beautiful. Is there anything else about the architecture that we should know for context?
I think that's the main part of the architecture. If I just look over it, looks complete, definitely.
Amazing. What does maybe for some more context, what does the team look like that's supporting this? You mentioned 8 to 10 engineers. What is the kind of team that's supporting this system and this scale? So
mainly, I think at Hashnode, currently we are 19 to 20 people, including the founders. 8 to 10 was for the initial product. Right now we are 12 developers and we are 2 teams. So we have a platform engineering team, which I lead together with a second colleague, with Yannick. And we have a core product team, which are developing features. And the platform engineering team, we see the core developers as our customers because we want to have this special knowledge and build the platform that other people can and other developers can work with it. In reality, we often, of course, also build features and also build most of the API is what we, for example, build. And they are also customers of Hashnode, our customers.
Makes sense. So you've got 12 developers, 19 people in total. Let's dive into a bit more of the technical details. I'm really curious about the caching piece, because running a caching company is one of the main use cases we see, of course, for caching is content websites, right? Hashnode is sort of a special example because you do sort of the community piece of it, but we see lots of just general news websites, right? Like Drive Australia or Rugby Australia, or some of our customers who are just publishing articles and then caching them, because you have a great use case for caching, right? All the data is relatively public. Everybody that looks at an article is looking at the same article. It gets published ideally once and then looked at a million times. It goes viral and everybody clicks on it, right? So in the best case scenario, it's a great use case for caching. So what does your caching look like throughout the system? Because it sounds like you've kind of got many layers of caching there to make sure that you can handle the traffic and the scale that you're at.
Yeah. So caching was really one of the main challenges in the last couple of months, I would say. Because when Vercel introduced get server-side props together with Next.js, that means we have server-side rendered pages. And these pages are cached on the page cache. So this is the first layer of our cache. The second layer of the cache on that side, if you just take our GraphQL API as an example, is Stellate. So we edge cache on Stellate our GraphQL responses. On the page cache works with SWR, so that means stale while revalidate. So we have data active on this cache once it is requested and the cache is filled up. We have active data on this cache. So people who are requesting the same data get fast responses. After a certain time, for example, after 3 to 5 seconds, so really short time frame, the cache is invalidated. So the next user gets still data with a marker that this could be stale data, and the backend gets the data from the origin again. This is the whole page cache. And what Vercel did after some update, they included ISR, which is incremental static regeneration. That means you can now invalidate this whole cache. The main idea here really is you have an API where you can say revalidate, and that's it. So now what you could do is you cache your data for 15 minutes or for 15 days. And once an update to this post happens, you can revalidate the cache, and that's it. So you have much less traffic to your origin servers, which is what you want in the end, right? The issue with that is that on Vercel and on Next.js side, you need to refactor a lot of things so that we basically can't do it right now without investing a lot of time into re-engineering certain things. This is why we still use the page cache with a relatively short time period. And this is where Stellate then comes in. So this was the main decisions why we use Stellate and why we use an edge cache on the API side. The interesting part here comes now with edge versus non-edge. So we have the page cache. You need to imagine this page cache is on the edge. Now the page cache has a miss, and we go to our Next.js server to get server-side props. The get server-side props again run not on the edge, but they run centrally, for example, somewhere in US East 1. So we make the round trip to the US, and then you make the round trip to Stellate, which is not on the edge anymore now because you were already in the US. So we have a bad latency again. So you can make get server-side props running on the edge again, but you see there are many things to consider, and it can be quite complicated. But this is the main part how we defined our caching at the moment. And we have a P95, so a latency of our 95 per percentile of under 200 milliseconds. So it is fine. So we don't need to over-engineer it here, but there are definitely things to improve.
I think one of the interesting things about what you just said about the page cache and incremental static regeneration is that it flips your sort of load pattern on its head. And what I mean is, when you think about caching, it's the same is true with any cache, right? It just depends on what you can cache and where you want to cache. But if you have a cache that can have really strong invalidation and consistent invalidation, where you know that because you have event-driven architecture, you know whenever things change, you can invalidate the cache whenever things change from the backend, right? You can purge the cache, and you can know that anytime any change happens, it gets purged. Then suddenly you can cache, like you said, for 15 days or maybe even a month or two, right? Because you know that when the data changes, it gets anyway purged and refetched. And what's really interesting is what that does, if you think about it, to the traffic pattern that your origin sees. If you can have a cache that consistently across your whole system works like that, then the load of your origin doesn't depend on how much traffic you get. It depends on how often your data updates, right? Because only when the data updates do you actually have to refetch the latest update at all the caches. But suddenly you've completely flipped your traffic pattern on its head and said, hey, the traffic we get is actually completely irrelevant because the cache handles all of it. The only thing that really matters is how often does the data get updated, which for use case like news, where again, hopefully an article gets published once and then never edited because there's no typos in it, or no corrections need to be made, right? And even then, that's a rare use case. You actually have very few updates. And so you can very much reduce your traffic by sort of flipping that traffic pattern on its head through consistent caching, which is really, really interesting.
Yeah, and this is exactly what we did with Stellate. So on Stellate, we have a purging API where we can purge some IDs or some scopes or whatever. And we have over 70 different types of events. And we have events for everything. If somebody liked a post, if somebody updated the headline in his publication, changed the color, whatever. And we have a huge function there which checks all of these different events and purges the cache then. And we have the ISR with Vercel kind of similar, but there are too many gotchas at this moment to do the same thing. So on Stellate, so with your company, this is working out great. So happy for that. Happy for using that.
Thank you for the plug. I think it's just something that I realized over the last 2.5 years of working on this company and actually one of the hardest parts is having all these events, funnily enough. If you think about a lot of large legacy organizations, they have, hundreds of microservices and 15 different databases that are hosted in 12 different places. It's very hard to actually know when and where data changes, right? But if you can architect your system from scratch, like taking this into account and going with this event-driven architecture, you're setting yourself up for a much easier integration for any cache later on, right? Because like you said, whenever somebody likes a post or publishes a post or edits a post, you know exactly what just happened and you can react to it appropriately, which is kind of amazing, honestly. And so kudos to you for setting it up that way.
Yeah, thank you. Also, the observability is super interesting then, because you see once I have a Stellate request ID I can make, or some API request ID, I can see the whole trace of what happened up to the whole asynchronous processing, what in the end, which email was sent out, for example. So that's also really cool if you set up new systems that way.
Nice, that's awesome. I also want to ask sort of about you mentioned that the GraphQL API is sort of like your public API that your end users can access to kind of fetch data from Hashnode and render it on their own blog, on their own domain, whatever they want to do. How has that been working out so far? GraphQL, I think, is largely used internally at organizations, right? And it's sort of used at these large enterprises to help teams collaborate better and kind of solve human problems through technology. How has it been working out to have external developers access the GraphQL API? What's the reception been like, and what have some of the challenges been like there?
Yeah, it's definitely another challenge to work with a public API versus an internal API, because internally we started out just building these services, naming them. If you want to rename something, we need to have some deprecation periods that for like the browser caches, but we never need to have proper communication around that. We are 10 developers, so that's easy to do. But working with a public API, it's quite different. First of all, you need to take care of security, rate limiting, and thinking about these things, because even if your API was public in nature before as well, it is a different kind of thing if you have proper documentation for it, how to use it, and people will misuse it. That's unfortunately the truth, what will happen. So we need to rate limit how often somebody can subscribe to a newsletter, for example. Everything which is email related is really sensitive because you destroy your email reputation. So security is one kind of thing, which is really interesting, what was a major change from what we did before. The second thing is deprecation notices, so in breaking changes. So if we want to change something now, to break any integration, we want that people build with our API and people build cool integrations and build their blogs. And we can't just change, post to blog post because it sounds better, and then we break all of these enterprises. So that's not a good way to do it. So second thing is really deprecation notices and communication ways. I think one large discussion and thought was also going into authentication, and you can get lost there how you actually authenticate yourself with public endpoints if you want to have everything public, because you can use integration keys, but everything which runs on the client can be misused from everybody. So this is really as basic as it is, this topic. Yeah, it gets really complicated how you do it in the end. So at this moment, we have a public API, and for all unauthenticated access, you don't need a key, you don't need anything, and you can just access it. And since we have a cache in front, everything is secured. Our origin systems are secured. I think these are the main differences, these 3 points.
Yeah, that makes sense. I think one of the things that's exciting about the last thing you just said is that's where I would recommend, I don't know if you folks use it today, but using stale by revalidate, right? Because if you can mark things as stale by revalidate, then even when you purge them, as long as you soft purge them, one of the scary parts about caching is when you purge your cache, suddenly everybody that's accessing the data that's purged is going through to your origin again. And Stellate, we do some deduping at the edge, right? So if multiple people request the same data from one edge location, it gets deduped and only one request hits your origin, but still you run the risk of triggering a traffic spike. Basically a synthetic traffic spike, right? Your traffic hasn't changed, but suddenly at your origin you have a traffic spike. And one of the ways to combat that is to use stale while revalidate, which will essentially keep serving the stale data until we get one run response back from the origin, updates the data, and then sends the new data to the users. And so your origin only ever gets one request per edge location. But I thought that's one of the really interesting bits that I don't know if you use it, but stale while revalidate could really help there with the public API to make sure that you're never triggering accidentally a traffic spike at your origin.
Yeah, we use it already as well on Stellate, on Vercel, both. That helped us a lot. Yeah. So no downtime. I have to say, before we had a downtime on MongoDB regularly, or at least once every few months, because of these traffic spikes, because of connections. And since we took care of caching, you really secure your systems. So we didn't had one outage because of that. Didn't need to wake up in the night because of that. That's a good sign.
Nice, that's awesome. And then one of the really interesting things about Stripe's API that I learned is that when you use Stripe, then they have a REST API, but it doesn't really matter. They give you an API version that is coded by the month and year of the release. So for example, you could be using the API version 2016-04 or 2023-08, for example, which is one of the latest ones. What's interesting is you can keep requesting your version of the API, right? So I have some products that I built a long time ago that are using Stripe API version 2016-04. I'm not even kidding. This is like 8 years old almost at this point. Now, when you think about that from an operational perspective, right? Stripe cannot run every single version of its API for 10 years straight. That makes no sense. You cannot have that many versions of your API running in production and used by customers. So instead, what they do is they have alias functions for any breaking changes that they make. So at any given point, they only run the latest version of the API, right? They run version 23, whatever, or 10, whatever the latest version is that they have right now. I'm still requesting for 2016-04, but every time they made a breaking change, they have a small function that basically translates through from the old version to the new version, right? And so I can keep using the version that's 2016-04, and it's basically alias to the latest version, and maybe eventually some features won't work anymore, or they will change the way they work, and that's fine. But broadly speaking, whenever there's breaking changes that don't have to be breaking, right, like renaming things or changing slightly how requests are shaped, things like that, they just have alias functions that translate the request through to the latest version and then response through to the first version. And so I'm still using 2016-04, even though really I'm using, they only run one version, but it just translates through back and forth, which I thought was fascinating and actually alleviates a lot of the deprecation notice and communication weight problem that you were talking about, because for most breaking changes, they're not actually that breaking, right? For me, it doesn't matter, right? If one of the fields doesn't exist anymore, it just becomes null, and that's fine, as long as I'm not using it, and even if I'm using it, it's null, then I just check that it's null and it's done, it's very easy to kind of evolve your API from there, which I thought was brilliant. You mentioned a few security things here as well. You talked about Cloudflare at the beginning with the DDoS protection. You talked about rate limits. What does that side of the house sort of look like? What problems have you experienced around security and kind of like attacks, and how do you combat them today?
So the main problem was also the most simple one, was the short SWR period, so the short stale while revalidate period, that if people write some scripts from different IPs, for example, and they come through the DDoS protection, because DDoS is, of course, it's not a DDoS attack if somebody's just requesting a lot of your blog posts. And at the beginning, we had a really, really short time period, and this was breaking the database. And the database, it was not even the issue that the load was too high, but what I've mentioned earlier is that MongoDB has a model of HTTP connections, or TCP connections. So once one consumer wants to connect to MongoDB, they open a client connection to the database. And you have a max of, for example, 5,000 connections. And if you scale now Vercel lambdas, if you scale 2,000 connections and all of them 2,000 lambdas and all of them open multiple connections, your database is going down just because of these incoming connections. So the main part to secure this was really having a cache in front that actually is cached for a long time and is only invalidated from the backend. So this was really the main security thing. The second one was having a rate limit in place for important mutations. For queries, they can use, I think, 20,000 requests a minute per unique IP. So we don't really have any rate limit in place for queries. But for some mutations, for example, like I said, the newsletter mutation, we don't want that somebody bombards some other newsletter, some other blog with new newsletter subscribers. So this is where we use some rate limits, where we say, okay, 10 requests per IP per minute are allowed, for example.
Got it. And for those rate limits, do you just run those in your kind of resolvers manually, or are those in Stellate? Are those in Cloudflare? What does that look like?
They're also in Stellate. So we also use Stellate for that. I think we were one of the first alpha users of this feature, and it's super easy for us to use this feature. We just have in the Stellate config, I think, a few lines of code where we say, if this mutation, if this field is called, then use this rate limit, and that's about it. We have a nice dashboard overview, because with rate limits is also a bit, you're always anxious that you block valid customers from using your product. So you have a dashboard for seeing this. So this was really nice to set this up.
Oh, I didn't even know that. I don't know how I didn't know that, but I totally forgot about it. I didn't mean to set you up there to rave about Stellate again. That wasn't my goal. I was just curious because I know that we built that feature, and so I was just curious whether you were using it or whether you built it by yourself. That's awesome. I feel like I got a really good overview over the architecture and some of the problems you've run into. Is there anything else that has been interesting about the journey that you've been on? Are there any technologies that you've had to remove or that you've had to evolve over time that didn't work?
I think the main part from what I've learned is really thinking about having a dedicated API from the beginning and thinking about the whole schema design really before doing it. This sounds super obvious, but with all of the Vercel API functions, they sound easy, they sound nice, but you can get in such a mess after a short time that it's really hard to maintain and to work with that. So this is really one thing. The second thing is NoSQL databases and relational data, because I think each data in each company, in each product is relational by nature. Just because you use a NoSQL database, that doesn't mean your data is not relational. And doing proper data design with NoSQL databases is not easy in my perspective. I use DynamoDB a lot with single table design, and this can work out good, but it's not the best developer experience. So if I would start something new, I would probably always go with a SQL database first, and just if you really hit the scale, then go over to NoSQL or DynamoDB. And I was a huge fan of DynamoDB in the past, and I still am, but like if you reach the scale, then you can think about it in my perspective. So this is one change I would do, because these outages we had were really simple, but really hard to figure out just because of the connections. So serverless and connections is really bad. I think these are the two main parts where I think differently as when I started out at Hashnode.
Beautiful. All right, Sandro, then thank you so much for coming on the podcast and sharing this overview with us. We'll link all of the blog posts that you've written also in the podcast episode description, so that for folks that are listening that want to dive even deeper, they can read more about your architecture and kind of dive into the written side of it as well. If they want to follow you or Hashnode, where should they go and follow along with your journey and with Hashnode's journey?
So we are both mostly active on Twitter. So twitter.com, Sandro_Wall. I'm pretty sure you put it in the show notes.
We'll link that too.
If you want to follow Hashnode, we have an engineering blog, engineering.hashnode.com. We regularly put out content over there, like how we build the GraphQL API, the architecture and everything. So I think that's a great place to check out.
Powered by Hashnode. So if you want to see what the product is like that Sandro works on, if you want to get an actual example, either go to hashnode.com or just dive right deeper with engineering.hashnode.com and look at some of the blog posts that they've written about how to build the system that you're reading those blog posts on, which is amazing. All right, Sandro, thank you so much for coming on. This was amazing. If you all enjoyed it, please go follow Sandro, go follow Hashnode, follow along with their journey. If you're an engineer and you're listening to this and you've been thinking about writing some blog posts about the things you've learned, just like Sandro was doing, either to share your knowledge or to further your career, go to hashnode.com, sign up, start publishing some first blog posts, and they will share them with all of their community, which is amazing. Thank you so much for coming on, Sandro. Talk to you again soon.
Thank you, Max. Really appreciate it. See you soon. Bye-bye.